Hello, ladies and gentlemen. This is Kevin Olson from TextLearn.com, and in this lesson, we will be discussing inheritance and polymorphism in Java. So, to get started here, inheritance is a feature of object-oriented program which allows us to create objects classes which inherit properties and methods from other object classes. So essentially, we have one object acting as a parent class up here, and then we have another object below that that's a subclass of it, and it inherits certain methods or properties, instance variables, and things like that from the parent class, and then we can go ahead and do additional things. And this really helps us simplify programming. So for example, here we have this Bentley Continental, this R8, and this Cadillac CTS. And they all have different features, of course, like the Cadillac has an OnStar safety system, the Audi has a Quattro four-wheel drive system, and the Bentley has a concierge service. But they all still have a top speed, a certain fuel efficiency, the 0 to 60 acceleration time. So if we wanted to create classes which model these cars, what we could do instead of individually adding instance variables for, say, top speed, acceleration, fuel efficiency, and some type of method to model the Quattro 4x4 in the Audi, because these first three properties are the same across all three cars, because they're all types of cars, just with one little thing that's different at the bottom there. Instead of writing each of these classes individually, we can instead create a car class, which would be the superclass here, and that would have the top speed, the acceleration, and the fuel efficiency. And then the Audi, Bentley, and Cadillac class would have their respective features that they each have. And they would inherit these top speed, acceleration, and fuel efficiency from the parent car class. And that way we only have to write the methods and the instance variables, fields, or whatever you want to call them, for top speed, acceleration, and fuel efficiency within our parent car class. And then the Audi, Bentley, and Cadillac classes, they just inherit that from the car class, so we don't have to rewrite those methods for each of the individual, more specific cars. And polymorphism, with regards to computer science, describes the is-a relationship object classes can have. And I believe polymorphism comes from a term in biology. That's what it's derived from. Not exactly sure what specifically it means with regards to biology, but with Java and programming, it just means that there's an is-a relationship. So a Bentley is a car, a Cadillac is a car, an Audi is a car. So those are all different types of cars, but they are all cars. So that's why they get these inherited properties from the parent car class. So for example, if we had a class that was a car, and then we were to extend that class in the Audi, and that's how we go ahead and use inheritance. In our class declaration, we use an extends keyword, and we'll get to that in 1 minute. But because an Audi is a car in our example, this statement here would be true. Car Audi A8 equals new Audi. Because an Audi is a car, we're allowed to say that this car is a new Audi. And then, for example, let's say if we take a look at the BigDecimal class, we're going to talk a little bit about big decimals. So I hope you've worked with those already. I know if you've been following my series, we've discussed this in the second chapter or the second topic or whatever. So we have this number, my number equals new big decimal. And if we look in the Java API, this is completely valid, because if you look at the Java API under the class for big decimal, we can see it says extends number. So a big decimal is actually a number. So it's extending that number class. So my number equals new big decimal with a value of 1. That is also a valid statement, because there's a polymorphic relationship between big decimal and number, those two classes there. So for example, if we had a sample car class right here, public class car, public car, so it's just pretty much an empty class that just creates a car with no instance variables, fields, or whatever. And then we wanted to extend that with an Audi class. We would create a separate class for the Audi, public class Audi, and then we have that extends keyword in there, so it extends the car class. So whatever instance variables and methods that are in the car class now become available for use within the Audi class. And in this example here, we're going to be extending the BigDecimal class. So let's go ahead and pull up Eclipse, and I will show you how this works. So I'm just going to create a new Java project here, and this is lesson 7.4, 7.4 dash, let's call it Inheritance, and I'll just click Finish. Okay, so let me add a testing class to this. So what we're going to do is we're going to create a BogusDecimal class. Alright, so this new class, we're going to call it BogusDecimal, and it's going to extend the BigDecimal class. So let's just create a new class called BogusDecimal here. And it's basically going to function exactly the same way a normal BigDecimal would function. So let's see here. So we're going to add to the class declaration up here, public class BogusDecimal extends BigDecimal. And of course we're going to have to import the BigDecimal class up here because we are using it. So we import java.math.bigdecimal. Alright, so the only thing we need to put in here is the public BogusDecimal constructor. So we have to have a constructor for that BogusDecimal, and there are different constructors available for BigDecimals, but for our purposes we'll just use the string one. So string val, and I have to capitalize that S. So public BogusDecimal string val, and then we use the super keyword, and what the super keyword does is it goes ahead up to the parent class and it invokes the parent class constructor. So this is calling the constructor that's provided by BigDecimal. So essentially all this is doing is saying call the constructor from BigDecimal, and we're going to pass that the string val. So we're basically creating a BogusDecimal. Whenever we make a BogusDecimal, it's going to be a BigDecimal with a string value. So that's basically all that we're doing there. So let's go ahead and create another class to test this. So let me save that real quick, and we will add a new class, and I'll just call this app, and we'll give that a main method. So what we have to do here is, again, I believe we have to import BigDecimal here because we're going to have to use that. So import java.math.bigdecimal. Okay, so that is taken care of. And now we can create a BigDecimal using our BogusDecimal. So BigDecimal, and we're going to call it imposter, equals new BogusDecimal with a value of 1.00. So now we created a new BogusDecimal, which is a BigDecimal, and we gave it the identifier imposter. So imposter equals imposter, did I spell it right? Imposter.add. And you can see here we have all of the methods available from the BigDecimal class with our BogusDecimal. So that we didn't have to write any of this in there. It's all provided by the Java API. So we do BigDecimal or imposter.add, and let's say new BogusDecimal with the value of 2. So we're taking our original BogusDecimal and adding a new BogusDecimal with the value of 2 to that, and then we can just do system out println imposter, and that will invoke the toString method from the BigDecimal class, which is inherited because of that extends keyword in BogusDecimal. So when we save that and run it, we can see that it prints out a value of 3.00. So that is essentially how extending things work, how inheritance works right there. You can see we extended the BigDecimal class with our BogusDecimal class, and we invoked the superclass constructor, and then we used our BogusDecimal class the same way we would have used a BigDecimal. We can even go ahead in here and add additional methods that would be specific to a BogusDecimal, but we're not going to do that right now. I want to move on to a separate example. Okay, so we're going to do a quick case study here where we're going to create a program which models different kinds of shapes. So we're going to have a shape class acting as a parent class. We're going to have a rectangle class which extends that shape class, and finally a square class, which extends the rectangle class. So we just have our shape up here at the top, the parent class, rectangle extends shape, square extends rectangle. So a rectangle is a shape, polymorphic relationship, and a square is a rectangle is a shape. So square is also a shape, and a square is a rectangle. And that is polymorphic as well, of course. And there is a UML diagram that we can take a look at. I think it's actually bigger if I click off of it. Oops. Let's see, how do I get rid of that? There we go. Okay, so we have the shape, the rectangle, and the square. The shapes will all have an area, and they will all have a name. So we're going to be naming our shapes. We can name them whatever they want, or we want them to be. And they're just going to be a string name. So the shape has a constructor with the string name, a method getArea, which returns a double, a toString method, which returns a string, setArea, setName, getName, so setters and getters for the shape. The rectangle, because rectangles are rectangular, they have a width and a height, and the constructor for a rectangle will take the name, the width, and the height as doubles, name as a string, and then it'll have additional methods, getDiagonal, and it'll override the toString method from the shape class. So when we print out a rectangle, it's going to say this is a rectangle named whatever with width and height whatever and a diagonal length of whatever. And then the square class is quite simply going to extend the rectangle class, and instead of having a width and a height, the square will have a side length, and then we are going to take that side length and invoke the constructor from the rectangle class. So we essentially just set the side length equal to the width and the height. So the square functions pretty much exactly like a rectangle, except it's going to just take one parameter as the side length instead of the width and the height, because of course the width and the height of a square will be equal. So let's go ahead, open up Eclipse. And let me delete, I'll leave my app.java file there. I'll just delete the bogus decimal because I don't really need it. Let's clear out the main method. Okay, so that is ready to go for when we're going to test this thing out. Let's create a new class. We're going to call this shape, and this is going to be our shape class, so public class shape. And if we go back to that UML diagram here, we need an area double and a name string. So we're going to have private area or private double area and private string name. So now our shape has a name and an area. So we have our constructor, so public shape, and then we have to pass that some, give that some parameters here. So we'll have public shape, and let me see if I did this with a default constructor. I did not. So we'll have the string name, and it appears that that is going to be like that. Okay, so string name, and if we get the name as a constructor, we set this dot area equals 0 and this dot name equals name. So that is our shapes constructor for a default shape, because we don't know what the area is. If it's just a shape, we don't have any parameters yet to set that kind of thing. So we have string name, and we have public double get area, and this simply returns the area of the shape. So return this dot area. We have a public void set area, which will set the area to whatever value we pass it. So double area, and this dot area equals area. So we set the area, so that's our getter and setter for the area field. And then we need a getter and a setter for the name. So public string get name, return this dot name, and then we have public void set name string name, and this dot name equals name. So now we have our setters and getters for the area and the name of the shape. And finally, we need a toString method, so public string toString, and this will return the name of the shape. So return the shape is named plus this dot get name, plus the shape is named oops, with an area of plus this dot get area. We could also just use this dot area or this dot name in there if we wanted to, but we created getters, so let's just use those. Alright, so that'll just return the shape with a name and an area. So let's test that out, see if it works. So shape, my shape equals new shape, and we have to give that a name. So I'm gonna call this, let's see, what's a good name? I'll just call it Bill. This shape is named Bill, don't ask me why. And then we do system out print line my shape, and we run that, and we can see this is a shape named Bill with an area of 0. So we know that our getters at least worked and our constructor worked, and we can assume that the setters also work because they're just so simple. Okay, so that is the shape. Now we're going to start working on the inheritance piece. So let's go ahead and create another class, and we're going to call this rectangle, and this is going to extend the superclass shape. So I can actually just type that right in there. And we can even have Eclipse generate the constructor for us. So I just want to show you what that does. So let's click that and click finish. And now you can see public class rectangle extends shape. So public rectangle string name. So this automatically created a constructor for us using the name and the super keyword. So that's invoking the constructor from the shape class. So this is a rectangle, which is a shape now. Let's go ahead and start working on the more specific fields and whatnot that go into the rectangle class. So we're going to have a private double width, private double height. And our rectangle class needs to have the string name, a double width, and a double height as the parameters. So we invoke the superclass constructor to create it first. So that goes first. We leave that alone. And now we're going to set the width and the height. So this dot width equals width. This dot height equals height. And we also should probably just set the area right here. But I did not, let's see, did I have an area method in here? Doesn't look like I did. Okay, so we'll set the area right here. So we can use super dot set area. So we're invoking the superclass set area method, and then we can just do this dot width. We could also just do width times height, but actually let's just do it that way. So width times height. No need to use this keyword there, even though it would be the same either way. But there we go. So we have our constructor for the rectangle class completed now, and we set the width, the height, and the area. So now let's go ahead and do a, let's see. Okay, yeah. So now let's go ahead and test this out just as is right now. Because we have a toString method in the shape class, we can actually just print it out just like that. So we can say rectangle, my rect equals new rectangle with a name of, let's say, a house. Let's say it has a width of 50 feet and a height of 100 feet. Very tall house, I guess. Okay, and then we can do system out print line my rectangle. We run this. Okay, and it says this is a shape named house with an area of 5,000. So we know that 50 times 100 is 5,000. So we can assume there that the rectangle constructor worked properly because it properly stored the houses, or the name of the rectangle, which is house, and it properly set the area using the given width and height. So now a few more specific methods of the rectangle class that we're going to do is public double get diagonal. And because not all shapes have a diagonal, this is appropriate to put in the rectangle class. So this will simply return the diagonal going from the top left corner to the bottom right, or top right to bottom left, as is shown here. So that's going to be our diagonal. And if you know the Pythagorean theorem, a squared plus b squared equals c squared, we can get the value of that diagonal by taking the square root of a squared plus b squared. So essentially the square root of the height squared plus the base squared, or the width squared. So get diagonal is going to return, and we can do this all in one line, math.square root. So we're taking the square root of this dot width times this dot width plus this dot height times this dot height. And that will give us the diagonal length of that rectangle. And we have to have a public string to string. So we're going to use another keyword here, override. And this is just kind of like a compiler thing. Whenever we use this @override keyword, I guess you would call it, in there, it is just indicating to the compiler that this is supposed to be overriding something. And it's really to prevent errors. So if we had a typo in toString, we don't have to have that override keyword in there. It'll still work either way. But let's say we typed toStrang or something like that, and it just came out weird. We had a typo in the method declaration up here. The override keyword would catch that. It would say like toStrang is not anything in the parent class. So there's no toStrang method in the shape class. There's a toString method in there. And then that override keyword will catch that, and the program won't compile, and it'll give us an error. And we'll know immediately that there's something wrong with this method. So use the override keyword just to kind of help you make sure you actually did override the method you intended to. So we're going to override the toString method from the shape class. So now when we create a rectangle and we print it out, it's going to go to the toString method in the rectangle class instead of the toString method in the shape class. So we can just return, this is a rectangle named plus this dot get name plus. And you notice that I can still use the get name from the shape class up here using this dot get name. I could also use super.getName if I wanted to. I'm not sure if I can just simply get name. I guess I can, but let's just use this dot get name to make sure we do that right. Okay, so with a width of plus this dot get width. Oops, do I have a get width method yet? I don't believe I do. Was that in my UML diagram? Let me check real quick if I wanted to put that in there or not. It doesn't look like I did. Okay, so we're just gonna say this dot width with the width of this width and a height of plus this dot height plus, and I guess we could also say the area, an area of this dot get area. So we have get name, get width, get height. Okay, so and a diagonal length of plus this dot get diagonal semicolon. It's quite a long string there. Let's go to the app, and now we'll just do the same exact thing. We'll leave that alone and try running it. Okay, so what did I have wrong here? Errors exist in my rectangle. The method getArea is undefined for the type string. Okay. This dot getArea, that should work. Plus this dot getArea. Did I have it missing something there? Okay, so yeah, I guess I was missing a plus sign there. Silly me. So when I run it now, it says this is a rectangle named house with a width of 50, a height of 100, an area of 5,000, and a diagonal length of 111.80. And that sounds about right to me. So now we know that the rectangle class is working properly, and we successfully overrode that toString method from the shape, because now it's not calling that, it's calling the one from the rectangle and not the one from the shape. Okay, so finally here we're going to create a square class, and the square class is going to extend the rectangle class. So we can just go ahead and do that. And if you recall what I said before, all we did with the square was we got rid of one of the parameters for the double width and height, and now we're just going to do double side length. So now it's going to just be super name, and it's the width height. Now we just replace both of those with side length. So when we create a square, it's going to get the name, and it's going to set the side length given to be the width and the height of the parent rectangle. So now we have that taken care of. Let's go ahead and test that out. So we can do square, my square equals new square box, and we'll give this a width of, or a side length, whatever, of 10. Go ahead and print that out. Print line my square. And now we run this, and it says this is a rectangle named box with a width of 10, height of 10, and an area of 100, diagonal length of 14.14. So that sounds right as well. Now another thing we could do is, instead of saying that this is a rectangle in the rectangle class, we could actually get the name of the object. So this dot get class dot get name. And what this will do, it'll get us the name of the class, and I had to put pluses in there. So now when I run it, it's going to say this is a square named box, but if I was to create a rectangle, equals new rectangle 100. So system out print line my rectangle. Oops, I need to give that another value. Okay, there we go. So now when we run this again, we can see it prints out the square first and then the rectangle, and it got the name of the superclass there. So this is a square and this is a rectangle, and that way we did not have to override the toString method again within our square class. So we just had to create the constructor, and the square class is done. That was pretty easy. So a quick question for you, I suppose, would be, how did Java know which toString method to use? So when we created the square and we printed out the square here, why did it go to the rectangles toString method and not the shapes toString method? Because they're different. A square is a rectangle, but a square is also a shape. So why did it go to the rectangle? This is because of dynamic binding. And dynamic binding means that the connection between the methods is being made at runtime. So when the program goes and tries to run this, it executes the code. What happens is it sees, okay, I want to print out a square, and then, okay, there's no toString method in the square class. So it goes bottom up. So it'll go first to the rectangle class. It says, okay, there's a toString method in the rectangle class. So it comes across that and it uses that because it's the first one that comes up. If I was to get rid of this entirely, which I will actually just do to show you, we can see now that when we run the program, and let's see, I should dock that at the bottom again. Now it says this is a shape named box and this is a shape named rectangle. So now that I got rid of the toString method in the rectangle class, it hopped up to the shape class in both of the instances. So bottom up from whatever one it comes across first based on what we extend, because the square extends the rectangle before the rectangle extends the shape. When we use the squares toString method, or when we try to print out a string from a square, it goes to the rectangles toString method first. So that's pretty much all I was trying to say there. So the review exercise for this lesson is to create a program which kind of models the relationship between teachers and students in a school, and we're going to, or you should create a person class. The people will have genders and names, so that's going to be the same no matter what, because all teachers have a gender and all students have a gender, all teachers have a name and all students have a name. It's going to have a default constructor for the person. The person, more specific constructor here with the string and the gender provided, the set name method, get gender method, and set gender method. So the setters and getters for the name and the gender. Then the teacher will have a more specific instance variable or field called the salary, which will be a double because teachers have salaries generally and students do not. So when you create a teacher, the teacher is going to extend person. And then we can do the constructor, which will have the string name, the gender, and the salary as parameters. And then it'll have get salary and set salary. And meanwhile, the student, instead of having salary, we're going to give the students a GPA. So student, default constructor, constructor with the GPA, and then the getter and setter for the GPA. And we'll also have an enumeration in there, which contains male, female, and unspecified. So quite simply, what I want you to do is go to my website, textlearn.com/series/Java intro, and this is topic 7.4, and download the school model project files. So go ahead and download that. And I did some of the code for you. I don't remember exactly what. So school model work files, and we can do file, let's see, import, general, existing project into workspace, and we select the archive file. Now we go to downloads and school model work files. So let's go ahead and import that. And now let's see, school model, here it is with a nice little X next to it, indicating that it doesn't work yet. So the goal here is to, let me close the other tabs. So we have genders. Genders is done for you. Person, and you need to fill all that in. And I put some comments in for you to follow along. So it looks like that needs the constructors and the getters and setters and the fields. Student, I put the GPA in there for you, but you still have to create the default and the specific constructor along with the getter and setter. Same thing with the teacher class, but with the salary. And then the test class is actually a JUnit. So how this works is with the JUnit test, once you finish completing these classes, you can run this test just like you would run any other program, and it'll give us some errors. It'll tell you which ones it passed and didn't. And it looks like I already extended the person class, so the inheritance test passed, but you can see here that the student class, the teacher class, and the person class did not pass. So what you basically want to do is implement those methods in a way so that these tests from this JUnit test case pass. And once you get all green marks here on the left, then you know you've completed the project successfully. If you have any problems, there is the completed file down available as well on the website. So you can download that, take a look at that if you're having any problems. And I will probably also make a short review video to show you how to do this. All right, so that concludes inheritance. It's been kind of a long topic. In the next lesson, it looks like we're going to talk about abstract classes, so that'll be interesting. I'll get into that soon. Thanks for watching and take care.